day. This is the Professor, CBMD PhD, and today's Wednesday, June 7th, 2023. It is 1:24 and 14 seconds, a.m. Eastern Daylight Time, and today's research, X-ray of atom. So let's jump to it here. The first X-ray of a single atom, date May 31st, 2023. Source, Ohio University. The scientists have taken the world's first X-ray signal, or signature, of just one atom. The groundbreaking achievement could revolutionize the way scientists detect the materials. As since its discovery in 1895, X-rays have been used everywhere, from medical examinations to security screenings in airports. NASA's Mars rover is equipped with an X-ray device to examine the materials composition of the rocks in Mars. An important usage of X-rays in science is to identify the type of materials in a sample. Over the years, the quantity of materials in a sample required for X-ray detection has been greatly reduced, thanks to the development of synchrotron X-ray sources and new instruments. As to date, the smallest amount one can X-ray a sample in an attogram that is about 10,000 atoms or more. This is due to the X-ray signal produced by an atom being extremely weak, so that the conventional X-ray detectors can be used to detect it. As atoms can be routinely imaged with scanning probe microscopes, but without X-rays, one cannot tell what they are made of. They can now detect exactly the type of particular atom, one atom at a time, and can simultaneously measure its chemical state. Once they are able to do that, they can trace the materials down to ultimate limit of just one atom. This will have great impact on environmental and medical sciences, and maybe even find a cure that can have a huge impact for mankind. This discovery will transform the world. As for demonstration, the team chose a hydrogen atom and a terbium atom, both inserted in respective molecular hosts, to detect X-ray signal of one atom. The research team supplemented conventional detectors and X-rays with a specialized detector made of a sharp metal tip positioned at extreme proximity to the sample to collect X-ray excited electrons, a technique known as synchrotron X-ray scanning tunneling microscopy. X-ray spectroscopy is triggered by photoabsorption of core-level electrons, which constitutes elemental fingerprints and is effective in identifying the elemental type of the materials directly. More so, using X-rays to detect and characterize individual atoms could revolutionize research and give birth to new technologies in areas such as quantum information and the detection of trace elements in environmental and medical research, to name a few. This achievement also opens the road for advanced materials science instrumentation. The study is focused on nano and quantum sciences, with a particular emphasis on understanding materials, chemical and physical properties at the fundamental level, on individual atom basis. In addition to achieving X-ray signature of one atom, the team's key goal was to use this technique to investigate the environmental effect on a single rare earth atom. They have detected the chemical states of individual atoms as well, by comparing the chemical states of an iron atom and a terbium atom inside respective molecular hosts. They find that the terbium atom, a rare earth metal, is rather isolated as does not change its chemical state, while the iron atom strongly interacts with its surrounding. Many rare earth materials are used in everyday devices, such as cell phones, computers, and televisions, to name a few, and are extremely important in creating and advancing technology. As through this discovery, scientists can now identify not only the type of element, but its chemical state as well, which will allow them to better manipulate the atoms inside different materials, hopes to meet the ever-changing needs in various fields. Moreover, they have also developed a new method called X-ray, excited resonance tunneling, that allows them to detect how orbitals of a single molecule orient on the material surface using synchrotron X-rays. And this achievement connects synchrotron X-rays with quantum tunneling process to detect X-ray signature of an individual atom and opens many exciting research directions, including the research on quantum and spin magnetic properties of just one atom using synchrotron X-rays. As going forward, the research team will continue to use X-rays to detect properties of just one atom and find ways to further revolutionize their applications for use in gathering critical materials, research, and more. And this is a professor on advanced physics, mathematics, computer science, and leader of research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.